Hi friends, in this video we are going to discuss about losses. Generally, in our DC machine, I will explain you in different manner. Losses are two types. Those are non-ohmic losses and ohmic losses due to resistance, without resistance. This non-ohmic losses again two types. One is the core losses. Another one is the, can you tell me what it's called? Another one is the friction losses. These ohmic losses are generally called as copper losses. Ohmic losses nothing but copper losses in general. This copper losses two types. One is the field winding copper losses. Another one is the armature winding copper losses. These core losses are two types. One is the hysteresis losses. Another one is the eddy current losses. We know that clearly. These frictional losses are three types. What are those? One is the bearing frictional losses. Other one is the brush frictional losses. And next one is the wind frictional losses. These field winding losses are two types. This is shunt field winding losses, series field winding losses, and armature winding losses is only armature winding losses. This is, sir, why you are doing like this much? We have losses two types. One is the constant losses, another one is the variable losses. Of course, but we are not explaining in DC machine like that. That is not clear explanation. I will give you why that is not clear, why this is clear. Just wait. Right. Now, in generally, hysteresis losses directly proportional to frequency. That's why these are directly proportional to speed. As usually, the eddy current losses are directly proportional to frequency square, which is directly proportional to n square. And same bearing frictional losses directly proportional to n, brush frictional losses directly proportional to n square, and wind frictional losses directly proportional to n cube. This is important. These are the on speed. And field, shunt field losses are ISH square RSH, and series field losses are ISE square RSE, and armature losses are IA square RA. This is simply the different losses. See here, generally these are the variable losses and these are the variable losses. Can you tell me this shunt field copper losses are variable losses or constant losses? Shunt field copper losses are constant losses because ISH is constant always. When ISH is constant, then shunt field copper losses also constant. So these all are called as constant losses. These all are called as constant losses. And these are called as variable losses. Now you can say variable loss and constant losses. This is simply the way of explanation for losses in DC machine. So variable losses and constant losses separately. They will ask you a question. What is stray losses? Stray losses nothing but, can you tell me? Stray losses nothing but the core losses plus friction losses combinedly called as stray losses, The non-ohmic losses is also called stray losses. This is important. The stray losses plus, what is that? Stray losses plus shunt field copper losses. Shunt field losses is equals to constant losses. This is important. This combinedly called as constant losses. This is simply about the losses in our DC mesh. Are you okay? Clear? Right. How they will ask you questions on losses? These are the two main questions for theory. What are the questions for problem? Let's see the problem questions here. Let's see how they will ask you questions or problems here. Right. First one, I said you hysteresis losses directly proportional to speed. If speed increases, hysteresis losses increases. If speed increased by 10%, then hysteresis losses also increased by 10%. As well as bearing frictional losses also. Bearing frictional losses also directly proportional to n. If this is increased by 20%, this is also increased by 20%. This is very simple question. Okay. What about next one? Eddy current losses. The eddy current loss is directly proportional to n square. For example, if speed increased by 10%, what about eddy current losses? Eddy current loss is directly proportional to increased by 10%, nothing but 1.1 n square. 1.1 n square, nothing but 1.1 square and n square. 1.1 square, nothing but 1.21 n square, because 11 square by 10 square. 1.1 nothing but 11 by 10. 11 square by 10 square, 1.21. Nothing but, what is the increment here? 21% increased. If the speed increased by 10%, then eddy current losses increased by 21%. As usually, if the speed increased by, for example, 30%, then eddy current losses directly proportional to 30% square, nothing but 1.3 square into n square, nothing but 1.69 n square. So, if speed increased by 30%, eddy current losses increased by 69%. So, simply, if the speed increased by 10%, eddy current losses increased by 21. If the speed increased by 20%, if the speed increased by 30%, this is increased by 69. If the speed increased by 40%, if the speed increased by 50%, what are the answers? Very simple. 10% increase, that's why 1.1. 20% increase, that's why 1.2. 30% increase, that's why 1.3. 40% 1.4. 50% 1.5. Nothing but 10% increase, nothing but 11 square. 11 square 121. 20% 12 square. 12 square 144. So 44% increased. 30% 13 square. 13 square 169. 69%. 40% 14 square 196. 50% 15 square. 15 square 225. 225 nothing but 100 plus 125. So 125%. Very simple question on speed. So what is that? Brush friction loss is also same. Like that, if they given wind friction losses cube, what is 11 cube? 1331, right? For example, wind frictional losses. Let's go for wind frictional losses. How the answer? Wind frictional losses directly proportional to n cube. n cube. If speed increased by 10%, then wind friction loss is directly proportional to 1.1 cube and n cube. What is 1.1 cube? 1.331 n square. So what is the increment here? That is nothing but here the increment 1. What is that? Here 11 cube by 10 cube. 11 cube by 1331 by 1000. So what is answer? 1, 2, 3. So 1.33. Of course 1. So what is the increment? 33% increment in wind. Like that you have to make it answers. Or 33.1% increased. That's it. Generally 33% enough. So like that they will ask you questions on our speed and losses. Are you okay? Right? Thank you.